that 1 kg of hydrogen is equivalent to approximately 4 kg of coal and 3 kg of gasoline, or you can say natural gas. And global demand of green hydrogen is increasing. We are presently it is in 90 million metric ton, and by 2070 we will be having demand of 500 million metric ton of green hydrogen. Now the major hurdle in this green hydrogen is, first one is production. For production, various methods are employed for this green hydrogen. Best one is coming out to be electrolysis of water, that by using green electricity which comes from the renewable source, whether it is solar or wind. And for producing 1 kg of hydrogen, we require 9 kg of ultra pure demineralized water. So, and ultimately, as we have discussed, that by 2070 the net emission zero, we aim for zero emission. So the major challenges in green hydrogen are production, then storage. After storage, it is transportation, and then use in different industry, whether it is transportation or chemical or steel industry. As a skill university, the aim of organizing this workshop was to, major aim is to establish the center of excellence in the area of green hydrogen. Ultimately, our aim is this one, and we are having various facilities available in our university in the form of center of excellence, whether it is in the form of various technologies will be used. It is welding, it is machining, it is solar technology, electric transportation and uses. So these different center of excellence we have already established. I think after finishing this one, we will have a two, and only thing we are left with the production or storage facility in the university. So the main aim of this workshop is this one, and I hope we will be able to achieve this aim. Thank you very much. It's very hard to have a session particularly after lunch, but Dr. Tapan has made it easy by introducing the Sholay story with the green energy or green hydrogen. When we are talking about green hydrogen, it's a source of energy. Energy, you know, it's of two types. One is renewable or non-renewable. When we talk about renewable energy, it is non-conventional. And when we talk about non-renewable energy, it is conventional. So a reverse thing is happening. Renewable is non-conventional and non-renewable is conventional. In non-conventional one, we are having your solar, wind, another sources of energy, and hydrogen is also added in this one. But when we talk about the conventional, that is your coal, hydrocarbon sources, etc. When the life on this earth started, it was very interesting that the only source of energy was present solar energy. But later on what happened, we have shifted to the another sources of energy which are now known to you as non-renewable. Hydrocarbon, which is you know as petroleum or oil and gas industry, it is the largest revenue generating sector in the world. And if we are talking about the 22-23 data, that it was around $5 trillion revenue was involved in this petroleum sector, and around 1100 barrel per day is produced, and total reserve we are having around 1600 barrel metric ton, billion barrels total reserves are this much. But this source of energy, which is easiest to handle nowadays, we are not going to last, and it is causing problem in environment also. Various type of pollution, water pollution, air pollution, impact on environment is happening. So we started for another sources of energy, that is we are looking for renewable one. One is solar. We started with solar. Then nowadays you know that solar energy is coming up very fast in India, and we are the, I think, third largest producer of solar energy in the world. Then with wind energy, as you know, cost is high. Solar energy also initially cost was 15 rupees per unit. Now it has come to 2 to 3 rupees. Now we are switching slowly due to environmental issue. Green hydrogen, hydrogen energy, which is later on from it is turned to green hydrogen, because we are already having gray or another source of hydrogen energy, but we are putting emphasis on green hydrogen, and present demand of our green hydrogen is around present production is 5 million metric ton, which is by 250 it is going to be 30 million metric ton, and out of which the green hydrogen will be 21 million metric ton.